How did life begin? I mean, really, how did a barren, lifeless planet give rise to, well, everything we see around us? It's probably the biggest mystery of all time, a cosmic cold case that's billions of years old. So let's put on our detective hats and follow the clues, all the way back to the very beginning.
All right, to get us started, here's our first piece of evidence. And it's a weird one. You, yes you, share about 60% of your DNA with a banana. I know, it sounds like a joke, right? But it's true. And it's not just a cool party fact. It's a huge clue. It tells us that if you trace your family tree way back, you and that banana have a common ancestor.
And that ancient relative? We actually have a name for it, Luca. That stands for the last universal common ancestor. Now, Luca wasn't the very first living thing. That's important. But it's the most recent ancestor that everything alive today, you, me, a mushroom, a banana, can trace its lineage back to. You can think of Luca as our star witness in this case, a tiny microbe living in a world without any oxygen.
But, see, this just leads us to the real heart of the mystery. Luca was already alive. So, where did it come from? How did the very first life, Luca's ancestor, spring into existence from stuff that wasn't alive? How do you get from rocks, water, and gas to something that can grow and reproduce? Okay, it's time to open up the case file.
Every good investigation has to start with the basics, right? You gather your raw materials, you look for clues, and for the origin of life, our first clues actually come from way out there, from the cosmos itself.
Now, when we say ingredients from space, we're not talking about aliens dropping off life on Earth. The theory of panspermia is a little different. It's the idea that the basic building blocks of life, these complex organic molecules, were actually cooked up in space and then delivered to the young Earth on comets and meteorites.
And what's wild is we have the receipts. We have found complex molecules, the very stuff of life, just floating around in giant gas clouds deep in space. A famous meteorite that landed in Murchison, Australia, was an absolute treasure trove. It had more than 20 different amino acids, the things that make up proteins. We've even found a funky property called chirality. You know, like how your left and right hands are mirror images? Life's molecules have a specific handedness, and we've spotted that same signature 25,000 light-years away. Space is a chemical factory.
I think the scientist James Lovelock said it best. He said, "The universe is like a big warehouse, with all the spare parts required for life available in it. So Earth didn't have to invent everything from scratch. The parts were delivered."
So, we've got our ingredients from the cosmic warehouse. The next logical step in our investigation is to head to the lab. Can we take those simple, non-living parts and recreate the spark that turned them into something more?
This idea actually goes all the way back to Charles Darwin, who imagined some warm little pond where life might have begun. That idea got a bit more scientific and became the primordial soup hypothesis. The picture is this: a body of water filled with chemicals, maybe from volcanoes, maybe from those meteorites, gets a jolt of energy, like a lightning strike, and that zap kicks off reactions that build the first complex molecules.
And in 1953, two scientists, Miller and Urey, decided to actually test this. They set up this amazing contraption of glass flasks, filled it with the gases we think were in Earth's early atmosphere, and then zapped it with electric sparks to simulate lightning. And you know what? It worked. After just a few weeks, that clear water turned into this murky brown soup. And when they checked what was in it, they found amino acids had formed all on their own. It was a huge deal. It proved that you could get the building blocks of life from just simple chemistry.
Okay, this is great. We have the ingredients from space. We have a lab experiment showing how they could link up. The next big question for any detective is, where's the crime scene? Where did this incredible event actually happen?
Now, that warm little pond on the surface sounds nice, but it has a major problem. See, early Earth didn't have an ozone layer. The surface was just getting blasted by sterilizing UV radiation from the sun. Any delicate little molecules trying to form would have been fried instantly. It was just too dangerous up there. So we have to look somewhere else.
And our leading suspect for the location is deep under the ocean, at places called hydrothermal vents. These are basically cracks in the seafloor. They're amazing because you're shielded from all that nasty UV radiation by kilometers of water, and they're constantly spewing out a hot, rich soup of chemicals and minerals. They're protected, and they're full of energy. A perfect nursery for life.
But we can get even more specific. There are different kinds of vents. You've got black smokers, which are scorching hot, hundreds of degrees, and really acidic. But when we study Luca's genetics, it doesn't look like it could have survived that. The evidence points to another type, called white smokers. These are cooler, they're more alkaline, and they create these perfect chemical imbalances that life could have used for energy. They're a top candidate.
All right, our investigation is really coming together. We have the ingredients, we have a chemical process, and we have a very likely location. So now, we've got to assemble the final pieces of the puzzle. How do you actually cross that magical line from just chemistry to real living biology?
The first huge hurdle is replication. To be alive, you have to be able to make copies of yourself, and this is where the RNA world hypothesis comes in. The idea is that before our fancy, complex DNA came along, there was just RNA. And RNA is amazing. It's like a Swiss Army knife. It can store information, like DNA does, but it can also act like an enzyme and get stuff done, including making copies of itself. It's the perfect starter molecule for life.
But a free-floating piece of RNA isn't a life form. It needs a container, a little house. And you know what? Chemistry solves this problem pretty easily. Fatty acids, which were definitely around back then, will naturally form tiny little bubbles in water, kind of like microscopic soap bubbles. These spheres could have accidentally trapped some of that self-replicating RNA inside. And just like that, you have the first protocell. You have an inside that's separate from the outside. You have a border.
So you've got replicating RNA inside a little bubble. There's just one final piece you need: power, an engine. That's metabolism. And this is where those hydrothermal vents become the perfect power plant. The vents were pumping out one kind of chemical soup, and the ocean outside was different. This created a natural energy gradient, like a battery, that these little protocells could tap into to power the process of making more copies of themselves.
And here's something that is so crucial to understand. None of this happened in an instant. This wasn't a single event. The journey from simple chemistry to the first living cells, then to LUCA, and then eventually to complex creatures like us, well, it was an incredibly slow, step-by-step process that unfolded over billions of years.
So when you follow all the clues, from the amino acids delivered on meteorites to the chemical reactions happening in the dark depths of the ocean, you arrive at this just breathtaking conclusion. The very carbon atoms that make up your body, the iron in your blood, all of it was forged inside a star that died billions of years ago. We are, in the most literal and profound sense, made of stardust.
And so, our detective story ends with one final massive question. If the ingredients for life are everywhere in the universe, which they seem to be, and if the laws of chemistry and physics are the same everywhere, then isn't it possible that this whole incredible process isn't unique to Earth? It makes you wonder, where else out there in the cosmos might this story be playing out right now?